This is going to be lesson 6, and I want for this to be an interlude of sorts. I want to talk about components and dynamic components and component attributes and the outliner. So let me make a component attributes, and also want to talk about solid component of functions, which I'll illustrate. Let's start with that. So far we've modeled exterior walls, columns, floors. We've yet to include some other elements, but let me show an example. Let's say I made a simple component that's composed of a rectangle, I don't know, 6 feet in height, about that big. Let's turn off X-ray mode. Triple click, and let's make this a component and call it solid 1. And let's create another one. And make that, I don't know, 8 feet in height. Did I make the last one 8 feet in height? Let's make this 9 feet. 9 feet. Enter. And make that a component. And call it solid 2. Okay, so these are two things separate from each other, and they're components. They're not remarkable components, they're simple components, but they have certain properties. And I'm going to illustrate that in what's called window component attributes. We have this error. We have to, I'm going to save this as, save as. Problem sometimes happens when you don't save via a drive letter. So we have a drive mapping here that'll allow us to reference that same documents location. So I'm going to go into the folder. Right. So lesson 105, yeah, replace it. Let's try that again. Window, component attributes. So solid 1 doesn't really have any attributes, but we could assign attributes to it, like a Z position. Z position would be where is it in 3D space along the vertical axis. And if I wanted to raise that 20 feet into the air, I could assign it a Z attribute of 20 feet, and that would raise it up 20 feet in the air. That's so solid 1 is way up in the air. If I set that back to 0, it brings it back to the ground. That's a really important concept to understand about components. There are functions you can perform with components called solid functions. Let's say these two solid components overlap like that. Right? If I turn on my X-ray mode, you can see that they intersect each other. Say I wanted, instead of for these to be two separate components, I wanted it to be one solid. I could select both of them and go into Tools, Solid Tools, and say unite them, union them. So that becomes, now this thing becomes one solid. It also, by default, makes that a group. If I undo what I just did, and let's try something slightly different. Say I wanted the intersection of those guys. I could select the two, Tool, Solid Tools, intersect them, and it's giving me what the two have in common. I could also subtract them. Subtract works a little bit differently. I go to Solid Tools, Subtract, invoke that command, select one solid and then the second one. You see what it did? So that's useful when you're creating things like furniture. Let's do the reverse. Tools, Solid Tools, Subtract. Let's do this first instead. So I subtracted that first shape from this one. That's a very powerful feature when you have to model things like a beam, for example, that sits on top of these columns. Let's turn on the AutoCAD. Let's create a miscellaneous layer just so I can get my stuff. Mist components. You probably won't need them. I'm going to take that and put it on that layer and hide the visibility of that layer. Let's turn back on the AutoCAD underlay and talk about what we have going on in this section view. Well, on the top of the columns exists a beam, and on top of that beam exist all these trusses. The height of the beam measured in the depth of that beam is 2 feet, right? So I have to somehow create that and put it up on top of those columns. I could do that several ways. I could try drawing geometry directly on top of the columns like this, right? And sort of take that element and start to extrude that and say, okay, we'll give that a height of that, and then stretch the end of that and make it, you know, sort of go this way with it. That's one strategy. That a better approach is this, and what I'm going to do is hide the other elements that I've modeled so far, and just look at this architecture plan and imagine I want a beam that covers all 4 of these columns and sits on top of it. Well, the strategy better employed is to draw it on the ground and then assign it a z value. So I could, let's see, one strategy is to draw a rectangle. I'm just going to move the edge of that rectangle so that it intersects the wall. I'm holding down the shift key so that it there's the shape, the outline of that beam in plan. We've assigned it the correct thickness. So if I hide my CAD underlay, I could take this, extrude it to a height of 24 inches, 2 feet. Is that right? No. Triple click, make it a group. Component attributes work both on any group geometry. It works on a group as well as a component. I'm not going to make that beam a component. I'm going to leave it as a group. I'm going to create a layer for it. Beam, or girder. I think we can use that. So girder. So we don't get confused. And take this and move it to that layer, to the beam layer. Right? So if I start turning back on all these other layers, that thing sits on the ground. So one thing I could do is select that shape and move it to the top of the columns, or I could go to Window Component Attributes and assign it a Z position. And if we know the top of that column to be 14.5 feet, I can give it a Z value of 14.6. And that effectively moves that to the top of those columns. So the girder is now sitting where it belongs at the correct height. So there's several ways of going about doing that. That is one of them. So how can we leverage component attributes to control the properties of components, in particular components that recur and maybe in different shapes or lengths or that type of thing. So that this is a girder now. Let's turn. Do we put it on the layer? Yeah. Let's turn off the floors and the exterior walls and see what we have so far. So we have a girder that sits on top of 1, 2, 3, 4 beams. It doesn't quite make it to the exterior. We won't worry about that so far. So now we have a bunch of trusses that sit on top of, that need to sit on top of that girder. And the trusses measure, I'm going to go ahead and draw a couple more dimensions here. They're 1 foot wide, and in height, they are 4.5 feet. So the useful thing about components is that I can use that information to model these recurring elements. So I'm going to model this first one that sits, let's look at the drawing in plan. Here might be a good use to create a couple guides. So I'm just going to sort of draw a guide that shows me the profile, right, of that girder. So if I were looking at it in plan and I drew a shape, let me turn, sorry, that truss, and I drew a shape. Let me turn off the visibility of the girder because otherwise SketchUp is going to snap to it. So if I created a rectangle according to that profile, right? Let's go to isometric view so we can see what I've drawn. There's the shape of the truss. Then I can take that shape, push it to a height of 4.5 feet, triple click and make that a component, and call it truss 1. Okay, and we have several instances of that occur along, that truss occurs at regular intervals atop the girder, which right now that's at 14.6. This doesn't have a Z attribute, but I could assign it a Z attribute. And so if I assign it a Z attribute of 14.6, right, that's going to make it coincident with the girder. So I need to add in another 2 feet there. So that should actually be 16 feet 6. And now it's actually sitting on top of the girder. Let's look at the section drawing again and see what we could ascertain. So it looks like 4 feet, every 5 feet occurs one of these trusses, so that if I array that in the direction, I'm going to tap the control key. Oops. In the direction of the x-axis, 5 feet, enter, and say 20x, 20 times. I've created an array of 20 of these. I could change that to 16x, 15x, 15x looks about right. But these are not the right length, right? It looks like they occur at the correct intervals. This drawing is defective, as are some of the things that we get from AIDC sometimes. The distance between this last element there's 4 foot 7 inches between the last truss, and so they're not exactly 5 foot intervals. We'll have to adjust for that. But for all intents and purposes, I've roughly modeled, right, the series of trusses where they occur. And if I turned back on the walls, we could see we have to make adjustments for the length and position of these guys. So I know that these 3 instances are correct. This one needs to be modified. So what I would want to do with that is make that one unique, and then replicate that as many times as I need to where it occurs in that. And then this one as well would need to be unique. And then the subsequent 1, 2, 3, 4 instances of that would be identical as this one. So we have 3 different conditions that we need to model here. Let's select this called truss 1. Well, let's first things first. Let's create a layer for trusses. And I'm turning off all this other stuff so I can easily select my trusses and move them to the truss layer. Okay. Turning on columns, the girder, selecting the instance of the truss that needs to be unique or different than the other components. Right click and say make unique. I'm going to select that face and move it in the direction of the green axis. I'm going to hold down the shift key so that I can snap to one of these intersections. So that guy now needs to be replicated across. You need to replace 1, 2, 3, 4, 5, 6, 7 of those with this. So I'm going to drag, move copy in the direction of the red axis, 5 feet, 7x. Let's identify the next unique condition. It would be that one. Actually, we have 2 more unique conditions. This one, make unique, double click to modify it. I'm taking that face, I'm going to drag it in this direction, hold the green axis, hold the shift key so I can snap. Is that right? No. Try that again. Endpoint, hold the shift key, snap to there. So that's an unusual intersection. That is partially it's coincident with the outside wall, so it isn't really unique from the one before it. But I'm going to leave that be. Then I'm going to take this one and make it unique. Let's start by moving it where it belongs. And then modifying it so that we select that face and make it the right length. There. So we need copies of it. direction, tap the control key 5 feet, 3x. Okay. So it doesn't align perfectly with the AutoCAD underlay, but it's for purposes of this model that's going to be sufficient. Because we identified that there's actually a bit more space in between the last instance of that. If I wanted to, I could take that component and move it to that endpoint. Then I think that would bring the distance between them to the correct place. Well, no, it's off by 2 inches, but I'm going to undo what I just did. And say that's going to be sufficient for what we've modeled so far. This was a rather longer lesson, but I think it's important to underscore components and component attributes and how you could use them to your advantage. Finally, let's talk about the outliner. The outliner is a way to identify everything that's in the Revit model, SketchUp model. So when I select any one of these, the instance is selected here. I could also select trusses in the outliner and identify them in reverse. That turns out to be a really useful feature when you're trying to globally replace elements like lights, instances of lights that want to be controlled and grouped together. So this is a rather long lesson. This is lesson 6, and we're going to stop there. The last solid element that we need to, there are 2 more solid elements that we need to model, and I'm going to talk about them in the next lesson.